All right, here's a couple good radical questions. The first one says to rationalize the numerator. And so you take the numerator, this one, and you multiply by its conjugate, that one. Perfect. And then you FOIL that stuff out. So you get root 4 plus minus root 21. Good. And then on the bottom, root 34 plus 187 plus root 10 plus root 55. Perfect. And then on the top, the middle two cancel. So root 4 is 2. Take away a square root of 121 is 11. So 2 take away 11 over root 34 plus root 187 plus root 10 plus root 55. 2 take away 11 would be a negative 9. So it's negative 9 over root 34. You can't simplify that, eh? 7 times 2? No. Plus 187. I don't think a pretty number will go into that either. So I think you're stuck with that. Same thing with 10 and 55. So that'll be your answer. And notice no radical on the bottom. Life is good. That looks good. Okay, here's another one. They ask you to simplify. So they're looking for, it's a cube root. So let me just rewrite it. So cube root of 405x to the 7th over cube root 15x5. So let's use the rule where you can go square root of a over square root of b is the same thing as the square root of the quotient of those two. Just so that maybe we can simplify things a bit. So I've got a cube root 405x to the 7 over 15x to the 5th. Okay, now 405 into, or 15 into 405. I bet that'll divide evenly. Let's say it goes twice with 10 and 15 into 105. What's that? You can do that on your calculator. Or maybe I can simplify it by 5s. 5 will go into that 21, and 5 will go into 15 3 times. And now the x's, dividing common basis, so subtract their exponents, would be x squared. And then you've got cube root of 21 divided 3 is 7, so 7x squared. Now they're saying cube root, so are there 3 identical things inside? There's not. I got 2 x's and just 1 7. And it's not in the denominator, so I would just leave my answer just like that. All right, hopefully that helps you with those two.